Random House Audible presents The Next 50 Years, Science in the First Half of the 21st Century. Edited by John Brockman. Read for you by Henry Levya, Simon Prebble, Jennifer Wiltsie, and Oliver Wyman.
Introduction by John Brockman. In 1991, I published an essay entitled The Third Culture, in which I introduced the idea that a new culture, a public culture, had come into being, which consisted of those scientists and other thinkers in the empirical world who, through their work and expository writing, are taking the place of the traditional intellectual in rendering visible the deeper meanings of our lives, redefining who and what we are. Science is the big news, and it is scientists who are asking the big questions. Through their books and articles, they have become the new public intellectuals, leaders of a new kind of public culture. The next 50 years pictures several aspects of this new culture. The essays presented here are not the marginal discussions of the old-style intellectual culture. The work of this group of scientists centers on developments that affect the lives of everybody on the planet. Consider the recent international press coverage of such issues as stem cell research, cloning, the sequencing of the human genome, artificial intelligence, astrobiology, and quantum computing. The topics, as well as the work, inevitably cut across disciplines. One of the reasons for the remarkable increase over the last 10 years in readership of books by scientists, including those who are contributors to this volume, is that they are compelled to write in language that their colleagues in other disciplines can understand. The generally educated reader thus benefits, because he or she can now join in and look over the shoulders of members of this group as they take on the big questions of the day. In this culture, and in the present book, scientists are not writing popularizations meant only to entertain the public. They are writing for and engaging their peers in other disciplines in the debates of our times. The goal is not the popularization of science, but the attempt to make the latest scientific research understandable within science itself as well as to a wide audience. That said, I do not claim that the authors of these essays necessarily offer better answers to the questions that arise in our daily lives than does any average person. The critical difference is in the quality of the questions they address. The subject and a starting point for these 25 original essays is the next 50 years, in the respective fields of the contributors. How will achievements in science over the next half-century change our world? How will they change the questions we are asking about who and what we are? What developments might we expect in each field or discipline? And how might these influence and cut across other disciplines? What current expectations will not be realized? And what will be the surprising shifts in perception? The book features thoughtful, challenging essays, intellectual adventures by 25 leading scientists, all of them frequent communicators of their science in books and articles for the general public. They are the biologists Richard Dawkins, Paul W. Ewald, Brian Goodwin, Stuart Kauffman, and Robert Sapolsky. The chemist Peter Atkins, the psychologists Paul Bloom, Mihaly Csikszentmihalyi, Nancy Etcoff, Alison Gopnik, Judith Rich Harris, and Jeffrey Miller. The psychologist and computer scientist John H. Holland, the psychologist and AI researcher Roger C. Schank, neuroscientists Samuel Barandes, Mark D. Hauser, and Joseph Ledoux, computer scientists David Galertner and Jaron Lanier, Rodney Brooks, director of MIT's Artificial Intelligence Laboratory, the mathematicians Ian Stewart and Stephen Strogatz, the astronomer Martin Rees, and theoretical physicists Paul Davies and Lee Smolin. Part 1 is an exploration of the future in theory. Among the topics, advances in cosmology, the use in mathematics of virtual unreality systems, new directions in complexity theory, speculations on what it means to be alive, on how we learn, on how we think, on the nature of our consciousness and how we feel, on whether or not we are alone as a unique form of intelligence in this universe. Part 2 explores the future in practice. It covers topics such as the future of DNA sequencing and what it will teach us about ourselves, the exploration of Mars and the search for extraterrestrial life, our command over matter, our intimate interaction with our machines, and particularly our computers, the future outlines of cyberspace, neuroscience, and the way we raise our children, and the prospects for our continuing physical and mental well-being. We are going through a rapidly accelerating epistemological sea change. We are using unprecedentedly powerful new tools, and in the process, as the Oxford biologist J.Z. Young pointed out in his BBC Wreath lecture in 1951, we are becoming those tools. What we have lacked until recently is an intellectual culture able to transform its own premises as fast as our technologies are transforming us. The next 50 years is part of this beginning, a place where empiricism and epistemology collide and everything becomes different, and where we begin to rethink our own natures and what kind of world we live in. That synergy exists in the work of the thinkers represented in this book and in their contributions to this book. John Brockman, New York City, September 2001. Part 1. The Future, in Theory. Lee Smolin, The Future of the Nature of the Universe. We are asked to predict the state of our science 50 years from today. 50 years is a long time, given the pace at which physics and cosmology have progressed over the last several hundred years. But perhaps it is not too long a time to make predictions that will not seem entirely stupid by then. If you look back over the history of science, you will see that often the important questions people were asking had been answered 50 years later. And yet, the progress of science has usually been slow enough that people speak roughly the same language as their colleagues working in the same field 50 years earlier. Let's look back 50 years then, and note what the big questions were. My own list would include 1. What is the nature of the strong force that holds atomic nuclei together? 2. What is the nature of the weak force responsible for radioactive decay? 3. Is the steady-state model of the universe right, or might there have been a Big Bang as speculated by Gamow and other fringe figures? 4. Do protons and neutrons have any internal structure? 5. Why do the proton and neutron have slightly different masses while the electron is much lighter than either? Why is the neutrino massless? What is the muon, and who ordered it? 6. What is the relationship between general relativity and quantum theory? 7. What is the right way to understand the quantum theory? I think we can confidently assert that now we know the answers to the first 4 questions. We're still working on the last 3, but the first have not been forgotten. Indeed, the methods by which those questions were answered form the basis of the training of a theoretical physicist today. If we look back 100 years, however, we find that we no longer care about many of the questions people were asking then. I'm not enough of a historian to write a list of questions asked by physicists at the turn of the last century, but they would likely have been more concerned with the properties of ether than with the properties of atoms. There was no evidence for the existence of physical atoms until a few years later, and indeed in 1900, many physicists did not believe that atoms existed. Others, like Ernst Mach, thought the question was not a part of physics because atoms would never be observed. As for astronomy, there was no evidence in 1900 for the existence of galaxies apart from our own Milky Way, nor did anyone have any idea what made the stars shine. So while physicists of the early 1950s would probably have understood the questions that physicists are asking now, no one at the beginning of the 20th century could have understood even the words that physicists were using in 1950 to talk to each other. Sometimes science changes so little over 50 years that it makes sense to try to predict what we will know after that span. But there are periods when progress is faster, and this is no longer the case. It seems that there is a horizon somewhere between 50 and 100 years into the future, beyond which it may be useless to speculate in any detail about the progress of science. Let's take a moment to consider why this is so. It's probably partly because 50 years is about the length of a scientific career, from the beginning of studies until retirement.
Sample complete. Ready to continue?